Greetings, beautiful people. We are back again. We are still on the series of circle theorems. Today we are discussing another theorem, which is known as the angles in the same segment theorem. What is a segment? Let's first construct a circle with a radius of 6 centimeters. So we have our circle. A segment is a region inside a circle cut off by a chord and an arc. A region, not a line, it's a region inside a circle cut off by two things, a chord and an arc. It means that the region is surrounded by these two things, a chord and an arc. It means that we need a chord. Now, what is a chord? I already explained that in our previous video about angles at the center theorem, but let me repeat it. A chord is a straight line connecting 2 points on the circle. So if you have a line that connects 2 points on a circle, that line can be described as a chord. So let's draw the chord. So we need 2 points, the first point B and another point C. Then we'll connect the 2 points. So we have line BC as our chord. Now we are saying that it's a region bounded by a chord and an arc. So let's look at this. So we realize that this is a chord and this is a minor arc, the smaller arc. So this region is known as a segment. This is also an arc and the same chord. This time we have a bigger segment. So we are seeing two segments, this side being the major segment, and this region as the minor segment. These regions are bounded by a line, that is the chord, and an arc. So the minor segment is bounded by the minor arc and the major segment is bounded by the major arc. Because you now understand a segment, let's start with the theorem. The theorem reads: angles formed at the circumference from the same chord or arc in the same segment are equal. I repeat it, in the same segment are equal. So let me circle equal. It means that the angles at the circumference formed from the same chord or arc in the same segment are equal. So it means that we need to create angles at the circumference from this chord, which is BC. So let's create the angles. We'll create one angle from this chord B. We have D, then we'll connect it with this line, which is T. Then we'll create another angle as well at the circumference, still from the same chord. Let's add another angle. So B to this circumference, then C to connect to create the angle at the circumference. So how many angles do you have at the circumference? You have 3 angles. Angle BDC, angle BEC, angle BFC. You realize that they are all coming from the same chord. And we are saying that if that happens, they must all be equal. And then you can see that they are all in the same segment. Look at it, in this segment. They are all in the same segment. You see that? They are all within the same segment. Let's measure the angle to verify this theorem. Let's measure angle BDC, BDC, that is 58.3 degrees. What do you think angle BEC is going to be? We are saying that angles formed at the circumference from the same chord or arc in the same segment are equal. If your guess is 58.3, let's verify. 58.3, the same. Let's measure the last angle, which is 58.3 is our angle. What if we decide to move the angles around? What is going to happen? If we decide to move the angles around, what is going to happen? Let's move angle BDC around. 58.3 still fixed. Why is it still fixed? This is happening because they are still in the same segment. If I decide to move it outside this segment and come to the minor segment, you can clearly see that the angle is 121.7, which is clearly not the same as 58.3. If I decide to move another angle, which is angle BDC, to this segment, now you can clearly see that these two angles are the same because they are in the same segment and they are being drawn from the same chord. You see the chord? The same chord. Once they are in the same region, the same segment, they will give us the same size. So take note of that. It has to be within the same region and from the same chord. And these are the conditions. Once the conditions are met, it will always work. So let's move it to the major segment. Once we move it, automatically we have the angle size, which is 58.3. If we change the size, automatically everything is the same. 40 anytime at it, check the 3 angles at the circumference, it will always be the same. Once they are facing the same direction within the same segment, they will all be equal. Do you see that? They'll always be equal. They'll always be equal.